Generally from this topic theory questions are asked, so please pause and read all these things. Let us see the question. During forward bias, the width of depletion region decreases and the barrier height is reduced. That statement is correct. And during reverse bias, it is the opposite. So both option A and B. Before we see the next question, let's discuss few basics. On the p side, number of holes are more and number of electrons are less, whereas on the n side, number of electrons are more and number of holes are less. So the holes flow from p type to n type and the electrons will flow from n type to p type. That is because it flows from higher concentration to lower concentration and they will be deposited at the junction forming a barrier. Now electric conduction in a semiconductor takes place due to both electrons and holes. So it is option D. Next question. An unbiased p-n junction has holes diffusing from p-type to n-type because of the concentration. So option 3, hole concentration in p region is more compared to that in the n region. Also read in detail about forward biasing, reverse biasing, minority carriers, majority carriers, doping, how p-type is formed, how n-type is formed, Zener diode. Read thoroughly on all these topics. Theoretical questions are asked based on that. Let us see the next question. A silicon has a concentration of 1.5 into 10 raised to 16. After it is doped with indium, the new hole concentration is 4.5 into 10 raised to 22. So what is the electron concentration formula? Ni square is equal to Nh into Ne. You have to simply substitute, therefore Ne is equal to Ni square by Nh. Now 1.5 square will be 2.25 and 4.5 into 5 is 2.25. So the answer is 5 into, and work out the power, it comes out to be 10 raised to 9. The charge carriers in a p-type semiconductors are large number of holes and small number of electrons. So you can expect theory based questions from semiconductors.